Hi students. So today I will come with another new topic which is orthogonality. First I will define orthogonality, then we will understand what do you mean by orthogonal signal. So orthogonality is the property that allows transformation of more than one signal over a common channel with successful detection. Therefore, orthogonality is the property that allows transformation of more than one signal over a common channel with successful detection. So we are transmitting multiple signal over a common channel. It is a common channel and we are transmitting multiple of signals. Suppose the signal is x1t, x2t, x3t and they are transmitted over a common channel. That is a common channel. And at the receiver end, suppose there is a receiver, for example, it is a receiver, the signal will be transmitted through this path, and at the receiver end we are successfully detecting all these signals without interference. That means these all signals can be separately detected without mixing. So these conditions must be satisfied in the orthogonality. Let's now we talk about orthogonal signal. The properties of orthogonal signal is two signals are said to be orthogonal if they are mutually independent. I am repeating again, orthogonal signal. Definition of orthogonal signal. Two signals are said to be orthogonal if they are mutually independent or not dependent. So if we have two signals, suppose there is two signal x1t and x2t. If we have these two signal and they cannot interfere with each other or they are mutually independent, then we can say these two signals are orthogonal signal. Then these two orthogonal signal can be transmitted over a common channel without mixing. Thereafter we can successfully detect this signal at the receiver end. So this property, that means a signal can be transmitted over, or one or more signal can be transmitted over a common channel if and only if they are orthogonal. Our next topic is finding two signals whether they are orthogonal or not. For this purpose, we require some set of rules. But before that, we should know one another topic related to this, which is called orthogonal vector. So, our next topic is orthogonal vector. From your 12th standard education, you already know about the concept of scalar and vector. The scalar quantity is defined by only the values, whereas the vector quantities are defined by both value and direction of propagation of that quantity. As you already know, here we are talking about a condition of vector, that is orthogonal vector. So, orthogonal vector is a particular type of or particular characteristics of a vector. Suppose you have two vectors A and B. You already know that the scalar quantity will be represented by a number only. Suppose A, B, M or N. Whereas the vector quantity is always represented by this arrow. Not only on the scalar value but also the direction. So, suppose you have two vectors A and B. And the angle between these and these vectors are, the direction of these vectors are like this way. This is A and this is B. And the angle between these two vectors are theta. Now, we will find out the projection on vector. If we want to find out the projection of vector, that is vector A on B, that means our goal is to find out projection of A on vector B. Here projection means shadow of vector A on B. So, if we put a light on the top of this point, the light will fall on this vector and it will create a shadow or a mirror on the second vector like this way. And the shadow part will be looks like this. So, this is called the projection of vector on B, where it is represented, I am representing it by AB vector. And from here you can see that magnitude of projection is simply equal to the magnitude of vector A cos theta, or that is the value of AB is A cos theta. And if we multiply the magnitude of projection AB with magnitude of B, that means here I am multiplying AB with B, it becomes A B cos theta. And the value is not equal to 0, or this value not equals to 0. So, again I am repeating here, the projection of vector A on B is represented by AB, and this magnitude of AB vector is represented by this equation, vector A cos theta. Now, if we multiply this projection value with the vector, second vector B, then after multiplication the equation becomes this, where A and B, that means this total value AB cos theta, vector A into vector B cos theta not equal to 0. Now, the value of projection vector, which is AB vector is already defined. So we can write that this way. The left hand side of this equation, just specify dot product of the vector. Here you already know the dot product, cross product, they are the vector representation or vector multiplication. So here is this dot value represents the scalar product or dot product of the vector. So we can write from this equation vector A and B, the mod of vector A and B not equal to 0. So here vector A and B are not independent and hence they will interfere with each other. That means if these two values will become 0, then only we can say these two vectors are independent with each other. But if these, here we can see here that these two vector product will not become 0. Therefore, they are not independent with each other and hence they will interfere when they are transmitted over a common channel. So, we cannot say that these two vectors are orthogonal vector. But if we have another vector like C, suppose here another vector which is C, it is your another vector, and it has, as you can see, by the same way, here if we put a light on this point, the shadow of this vector on B will just becomes a point. It will not create any value. Just a point. Therefore, it is a null vector. Null vectors means, so it is a null vector. That is C of B, which is the projection of vector C on B, is a null vector. Where null vector, that means a null vector represents the magnitude of this vector is 0. So the projection of vector C on vector B is always 0. Also here the theta value is 90 degree, as you can see here. Here theta value is not equal to 90 degree, but here the theta value is 90 degree as it is perpendicular with the plane or with the vector B. So again we come to the same equation and represents this vector in terms of this equation. So we can write C, we can write vector CB into vector B equals to vector C, vector B cos theta. And here the theta value is equal to 90 degree. And you already know that the value of theta, cos theta for 90 degree value or cos 90 degree is equal to 0. Therefore, these two dot product will create a value 0. And in this case, we can say vector CB and vector B are independent with each other and they will not interfere by this way. So we have some idea out of the mathematical relation between two vectors, whether they are independent or not. So the property will, you have to remember that the dot product of two vector must be 0 for a orthogonal vector, and number 2, the dot product is a type of inner product. In case of signal space, this time I will move to the vector to signal. So the same concept will be applied for orthogonal signal also. So in case of signal space, the typical inner product is called the definite integral. So if we have two signal, suppose x1t and x2t, we have only two signal and suppose they are orthogonal, then their integration over the total time period that the signal exists is 0. Or mathematically we can say that if we integrate these two signal over the time period where it exists, where the signal, both signal exist, after integration the value will become 0. Okay, and this condition is true for a aperiodic signal. This condition is not true for periodic signal. This condition is true only for aperiodic or non-periodic signal. Then we will use the condition to find out whether they are orthogonal or not. That means if you have two signals and first you have to find out, suppose you are given two signals. So first you have to find out whether they are periodic or not, and if they are non-periodic, then you can apply the same rule to find out whether the signals are orthogonal signals or not. So this is condition for non-periodic orthogonal signal. So what is for periodic orthogonal signal? So now I move to the topic. The same condition is true for orthogonal signal and for periodic with some modification. As we already know, the periodic signal has a fundamental time period which is called t. So if two signal x1t and x2t are periodic, they are periodic signal and their fundamental period is t, fundamental time period is t, then if we integrate within this fundamental time period, that is 0 to t, or it may be minus t by 2 to t by 2, and we integrate them within this time period, then after integration, if the value becomes 0, then we can easily say the signal will be orthogonal signal. Now we will talk about properties of orthogonal signal. So the first property will say two harmonics of different frequency of a periodic signal. Of course, this condition is true for periodic signal. So the first property will say two harmonics of different frequency are always orthogonal. Again, I am repeating property number 1. Two harmonics of a periodic signal or of two periodic signal. It's not a, it's a two periodic signal of two different frequency are always orthogonal. Suppose you have x1t, which is a value of sine n omega 0t plus phi 1, where phi 1 is the phase of the signal and n omega 0t or n omega 0 is the frequency of the signal. And you have another signal which is x2t, which is represented by sine m omega 0t plus phi 2, where phi 2 is the phase of that frequency, that signal, and m omega 0 is the frequency of that signal. And if we compare these two signals, we can say the phase of two signals, that is phi 1 and phi 2, are different. Also, the frequency of the signal is also different. Here you can see in the case n omega 0 in the first case of frequency, and in second case of signal the frequency will be m omega 0, and always m not equal to m. If they are same, then this condition is not true. But if they are different, that means the frequencies are different of two signal, then if we integrate these two harmonics over the time period 0 to t, then their value will be 0. Again, I am mathematically represent this condition as integrate by this time period sine n omega 0t plus phi 1 into sine m omega 0t plus phi 2 dt is equal to 0 for a orthogonal signal. Now we move to the second property. In second property, sine and cosine signal with the same phase and same frequency are always orthogonal. So, I am writing here sine and cosine signal with their same phase and frequency are always orthogonal. Suppose we have x1t equals to sine n omega 0t plus phi and signal x2t will be represented as cos n omega 0t plus phi. You can see here in both two cases the frequency and phase are same, whereas these two signals are sine, one is sine and other is cosine. That means according to this rule, integration of minus t by 2 to t by 2, integration over this time period, if we integrate these two signal, the value will becomes 0. move to third property. DC value and sine functions are always orthogonal. DC value and sine function are always orthogonal. This means integration over this time period with a DC value and a sinusoidal signal is always 0. Here A is a DC value and it is a periodic signal. And if you integrate these two quantity over this time period, its value after integration will be 0. And the last property, we will say that effect of orthogonality on total energy and average power calculation. That means the last property tells about effect of orthogonality on total energy and average power calculation. If we have two signals x1t and x2t and these two signals are orthogonal, then integration of x1t and x2t over its fundamental time period will be 0. Again, I am representing this with a mathematical integration. Here are two signals x1t and x2t. And these two signals are supposed to orthogonal. Therefore, if we integrate them over its fundamental time period, its value will be 0, as I already discussed. So here these two signals, suppose these two signals are orthogonal and they are periodic. Then according to our previous discussion, we already know that if we integrate them over the fundamental time period, the value will be 0. And if they are aperiodic signal, then also this fundamental time period will be replaced by the total time period, whether the rest of the equation will be same and the value will be 0 after integration. It is the property that I already know for a orthogonal signal, whether they are periodic or aperiodic. So now we move to our fourth property, that suppose you have another signal. You have already two signals, they are orthogonal, and you have another signal, suppose it is yt, which is equal to sum of x1t and x2t. So you are given to these two signals and they are orthogonal, and you have another signal which is yt, and the condition of yt is they are summation of these two signals x1t and x2t. Then the average power py, which is the power of signal yt, is always the sum of average power of signal xt and x1t and x2t. It is the property of a orthogonal signal if they are periodic. Because you already know that for a periodic signal, we cannot find out the energy, we can find out the average power. So, the signal yt is given to you, which is summation of these two signals x1t and x2t, and its average power is py, and x1t's average power is px1, x2t's average power is px2. Then the average power of yt is similar to total average power of signal x1t and x2t if they are orthogonal, if these two signals are orthogonal. This is for periodic signal. Now for a aperiodic signal, the power will be 0. So therefore we cannot find out the power. So here we find out the energy. The condition is same for aperiodic signal also, but in this case we have to find out the energy. So if the x1t and x2t signals are aperiodic in nature, suppose aperiodic in nature, and yt is another signal where this yt is again the summation of x1t and x2t, then average energy of total energy of yt must be total energy of x1t comma x2t. This is for periodic aperiodic signal. This is for periodic signal condition, this is for aperiodic signal condition. So all these conditions for periodic and aperiodic signal is true if the signal x1t and x2t are orthogonal in nature. So these four properties are present for a orthogonal signal. So now I am ending my class here. Thank you.